It's a pleasure for me to make this presentation about two themes that I've been working a lot for several years: modular construction and mass customization. They are very, very well connected. And I'm going to talk about some challenges and opportunities about those two themes. So this is the summary of my presentation. I'm going to start talking about the evolution of industrialized construction. Then I'll explain some core concepts, some trends in modular construction and mass customization. At the end of my presentation, I'll make a connection also with sustainability. Those two themes are very well connected to sustainability. And I'll close my presentation by talking about some research opportunities about these two topics. So I understand that this course is about digitalization in construction. So you probably have already been introduced to the evolution of the industry and how the digitalization has influenced the evolution of the industry in the last few years. I'd like to start my presentation talking about this evolution about that happens in manufacturing and that affects also construction, which includes not only digitalization, but also changes on the way we manage the industrial production, right? So we have Industry 1.0, the first industrial revolution in the UK, 18th century. Then we have the second industrial revolution, mostly in the United States. That's when the mass production ideas emerged. Mass production, assembly lines, standardization, right? So that was a very important change in manufacturing, in which traditional activities were replaced by repetition, mechanization, standardization. And then we have Industry 3.0, which happens in the 1970s, in which some degree of automation was introduced in manufacturing. So we started to have more computers, and that's a period also when we started to use some different concepts from mass production. Started slowly in the West, right? Concepts that have been developed in Japan for a few decades. Things like Pokayokis, Andon systems, and so on. And in 2011, we had the idea of Industry 4.0 emerged, in which more advanced computing systems were introduced. Companies started to work with a large amount of data collected in real time. Then we had also some other innovations related to the use of internet, right? So this is, I like this very simple definition of Industry 4.0. So it combines digitalization and automation of production units, right? Or services. So it's not only in the manufacturing plants, it can be related also to services. And a second component of Industry 4.0 is the creation of a digital value chain. Is when the companies are integrated. The companies are production units, they become digitally integrated, which creates many opportunities for improvement. Some of the technologies that you've seen in this course, like digital twins, automation in quality control, are examples of applications of some of the ideas of Industry 4.0 in construction. One important thing is when we introduce this new approach for digital systems, is that there is usually a change in management, right? So there is for some years there is a discussion: what is the new managerial philosophy for Industry 4.0? Is it lean production, which became very important since the 1980s, or it's something else, right? So what the literature says is that there is a very strong synergy between Industry 4.0 and lean production or lean management. By synergy, I mean lean management contributes to the introduction of Industry 4.0 because it brings a process vision, it brings an approach for standardizing work, it improves layout, physical organization of production, it brings the idea of visual management and other concepts that really facilitate the introduction of Industry 5.0. And the opposite is also true. Industry 5.0 increases the effectiveness of lean practices like Kanban, standardized work, reduction of cycle time, waste elimination, and so on. So this is positively affected by the introduction of digital technologies that are connected to Industry 4.0. And I'd like also to point out the role of building information modeling, right? This has been very important for the introduction of the Industry 4.0 in construction, because BIM has brought to construction the idea that digitalization must be focused on core elements of construction. So it's very much about product modeling and also process modeling. So these are some examples that explain a little bit this synergy. So an important change that people talk about in construction now is, well, visual management is a very important concept in production, right? And visual management traditionally has been something with a low level of digitalization. So traditional visual management is based on cards, physical devices, boards, colors, and so on, right? And nowadays people talk about digital visual management, which is a very important change, right? And there was a few years ago there was a discussion whether it's possible to make visual management fully digital, right? Probably not. Probably we still have some physical elements of visual management, traditional visual management devices, but there are several studies that provide evidence that digital systems in visual management can bring several benefits, right? One of them is that we can have more dynamic visual management devices. We can have information in real time. We can have dashboard. We can visualize products. We can have, in some situations, the visualization of different information at the same time, which is very, very beneficial. This is an example, a company from the UK, Arcadis, which is a company that designs infrastructure projects. They started in the pandemic to making this transition towards digital visual management, and nowadays they use these several technologies to uh, support collaboration, to display information in real time, and so on. This is a study developed by one of our students, Barbara Pedot. Another example, this is not part of a research project. This is a site visit that I did a few years ago at a DPR construction site. DPR is a company from the United States, very advanced in Lean. It's a leader in the implementation of Lean construction. And one of the things, I saw several things in this construction site, but one of the things that was very interesting, it was this very small robot, not very expensive. And this is a robot for marking, right? For defining the position of drywall partitions, for instance. And I thought it was a very useful device, very useful robot, because it does a task that is very important, marking, defining the right position for construction components. And also it eliminates an activity that is difficult, it demands skills. It's hard to do it because the position of the work is not very comfortable, right? And so it's excellent idea, right? And I'd like to point two things about this change, right? First of all, you can see in the right picture, the guy who manages the marking system. So we don't need anymore a worker for doing that manually, but we need a different type of worker who is somebody who has training for operating this equipment, right? So it's a much more qualified work. It's much more interesting. It's much better in terms of working conditions, right? So this is a key mechanism for developing the construction industry, attracting people that are interested in much better careers, right? So this is the first point. The second point is, in order to do that, you need a very clean construction site, a very organized construction site. You need also to have a very tight quality control of construction elements. So if you don't have a very regular flow, you will not be able to operate this small robot. So these are two examples of changes that, of course, they involve digital technologies, but they also involve an improvement of construction site conditions that you're only able to do that if you have a different managerial philosophy. And lean production, lean management can help on that. So what I'm trying to say is that industrialized construction has existed for a long time, right? But nowadays we have a different type of industrialized construction. In the past, industrialized construction was related to mass production, to standardizing not only processes, but also products. It was related, of course, to mechanization, to offsite prefabrication. Most companies that industrialize construction, they had to be very big, very big manufacturing plants, so they could benefit from the scale, have economy of scale. But these companies, they usually provided delivered projects or provided components that didn't have a very high quality, right? So traditional construction was always considered to be better, right? I remember comments like that. Well, if you build a brick wall, that's a real wall, right? It provides you with thermal comfort. It's much nicer than to have some kind of light panel or something like that. And what we have now today, it's a new model of industrialized construction. It's a model in which customization is possible, right? Is feasible. Companies can compete by providing some degree of customization. I'm going to explain more about that later. You can have standardization and at the same time flexibility by using different strategies like modularity, additive technologies, and so on. Mechanization is not only for repetitive operations, but you can have flexibility because of digitalization. You can get, for instance, a digital design of a product you put in a machine that can produce different products within certain limitations, right? Without adding much cost to the operations. So in this context, we see now companies that deliver prefabricated projects with a very high added value, right? Not only industrialized buildings that are a combination of very simple components. So the components can be very sophisticated in this context. Another important topic is to involve several companies in the delivery of prefabricated projects. So the idea of open systems has grown a lot around the world. And the idea in this model is that industrialized construction can deliver projects that are at least equivalent or even have superior quality to traditional construction. So we have examples around the world. I suggested for reading one paper about modular construction in Sweden, which is a country that is very advanced in modular construction. I'm going to talk a little bit about Japan, which also has a very, very well-developed modular construction sector. Right. So what is modular construction? The concept of modular construction involves several ideas, and sometimes it's difficult to define a strict limit of what is modular construction and what is just prefabricated construction. A general definition of modular construction is a construction process in which a large share of activities are executed off-site in a controlled environment, in a plant, which can be highly advanced or maybe not so advanced, and has a high degree of mechanization, right? Some people think modular construction is about delivering components that have 3 dimensions, right? That's not true. Typically, modular construction involves panels or volumetric modules, right? But you can have also some components that are not 2D or 3D components, right? You can combine different types of components in modular construction, but typically they have a higher degree of completeness compared to traditional construction. And this is a very important thing. The integration of components is undertaken in an industrial environment. So it's not only the components are produced in an industrial environment, they are integrated, right? They are assembled, or even if they are not completely assembled, the production in an industrial environment allow these components to have a very effective, very reliable interface between components. And finally, this is also very important. In modular construction, you adopt the concept of modularity. Right? Modularity is a concept that comes from the field of product development. There are different types of modularities that I'm going to explain soon. So some limitations of modular construction, or limitations in terms that in many cases, the ideas of modular construction that I presented in the previous slides, they're not fully implemented, right? For instance, many modular construction companies do not deliver a combination of highly repetitive standardized modules produced by semi-automated production lines, right? Some people use this expression, that plant of the plant of that company is a construction site with the roof, right? So many companies just use the idea of production of off-site production protected from the inclement weather, right? But it's not actually it doesn't have a high level of industrialization, right? Although there are companies that are very advanced in that respect. Another limitation is that when you deliver what we call a modular construction project, a project that involves a large percentage of industrialized modular components, right? You always have part of the project that involves traditional construction activities, right? You need to do earthworks, you need to do foundations, you need to do some activities that cannot be fully executed in a prefabrication plant, right? Another difficulty is that, especially when we have long distances, when you have problems in terms of transportation, you might not be able to deliver modules that have a very high degree of completeness, right? Because it becomes very expensive to transport in a country like Brazil, for instance, to take modules from the south of Brazil to Bahia, for instance. That's a long distance. So you might opt for not sending the volumetric modules, but sending panels or sending components, and having another plant for assembly or assembly on site, right? Or maybe delivering the shell of the building and then doing some traditional work like finishings, ceramic tiling, and things like that in the construction site. So many companies do that. They combine the production of some components in a manufacturing plant and execute part of the work on site. And another thing is that people do not, and when I talk people, people from the industry do not understand well the concept of modularity. So they are not able to fully explore that concept, right? I've had the chance to visit several modular construction plants in Brazil and also in other countries, and not all of them adopted the concept of modularity, although they might deliver volumetric modules. Well, if any of you would like to ask a question, if you have any doubts, you can please interrupt me. I'll be happy to clarify. Okay. Okay. So these are some examples. First, some companies from Brazil, Tec Verde, a company that was started in the state of Paraná. Now they moved to São Paulo. A company that I followed the evolution because it was a very innovative company. They work with wood frame. Another company from Paraná, which is very different, Espaço Smart. Espaço Smart is a company that have shops around the country and also in some other Latin American countries. And they deliver steel frame houses, right? But Espaço Smart, they don't assemble volumetric modules in the manufacturing plant. They produce kits, right? And they have an extensive network of designers, construction companies that provide services for specific projects, right? So they deliver the kits, they train these companies, and they assemble the houses in the construction site, right? Is it modular, right? Well, it's a modular design building, right? But it's not, they don't provide volumetric components, right? So these are two different completely operations. Tec Verde delivers panels, right? They usually they don't assemble in the manufacturing plant. That's Visia, a company from Rio Grande do Sul. This company delivers different types of projects, prisons, schools, healthcare units. Recently, they started producing housing projects, especially after the big flood of 2024. This company, they work also as a contractor, so they deliver the whole solution, right? They produce modules in the manufacturing plant. They are typically volumetric modules, but they also do other tasks. For instance, a prison project, they have walls, they have sometimes sewage treatment units, things like that. So they deliver everything. They provide a full solution for the client. This is a dilemma that many companies face. A company that delivers the whole project, it provides a full solution for the client, right? If the company only delivers prefabricated components, who is going to do the rest of the project? Is it a traditional construction company? Is it necessary to have two contracts? one with a modular construction company, one for a traditional contractor. What the experience shows around the world is that companies that opt to sell modules, to sell components, they become very vulnerable in the market, because typically clients want a complete solution. They don't want to buy modules and then find another way to deliver projects. I'll give an example. After the flood in Rio Grande do Sul, there were some opportunities for using industrialized construction that were created, and the government, the state government of Rio Grande do Sul, they had a competitive bidding for the delivery of modules, but some of these projects haven't happened yet because the local government, they haven't managed to build the infrastructure yet for those projects. So it becomes very complicated when you have to divide in different contracts. So which are the most developed cases of implementation of modular construction? Sweden is one case. Not only Sweden, but Scandinavian countries are very good. There are many good experiences in Canada, in United States, in the UK. UK has a very large number of modular construction companies, but perhaps the most advanced one is Japan. Japan has a very advanced modular construction sector. It started by this segment started to grow in the 60s. There was some kind of support or coordination by the government, right? And now there are a number of companies that are able to deliver highly industrialized buildings, especially housing, right? And in the housing segment, especially individual houses, this is a relatively large market in Japan, right? And these companies, they develop technologies, they have labs, some of them have research institutes. Of course, there are different types of companies, but there are 5 very large companies that are the ones that lead the delivery of modular houses. So they're very advanced in technology. They're very advanced in the application of lean production ideas, right? This is just one example, right? One manufacturing plant that has a production line. Typically, it's a U production line, like in any lean manufacturing plant. And there is a takt time of 5 minutes. So every 5 minutes, a house moves in the production line to the next workstation, right? So these housing manufacturing plants, they have produce a large number of modules. They have a very high throughput, something like 3 houses a day. Each house has between 12 and 13 modules. However, these companies, they are very good at dealing with the customer, right? So they're able to capture requirements, right? They have something like showrooms in which the customer can choose different components. They can experiment some attributes of the buildings, right? And these companies also provide additional services like warranties, checkups in the houses after delivery. They have some complementary repairs. They have a 24-hour, 365-day hotline. This is a paid service, but they can provide that. They have free inspections for 10 years. And some of them now are exploring the market of deconstruction and recycling those houses, right? So what I'm saying is that those companies are not good only in industrialized construction technologies, in lean production, but they are also very good at dealing with the customer, fulfilling the specific requirements of the customers. So if you see some pictures I haven't got pictures from different types of houses, but if you look at the houses produced by those manufacturing plants, they are typically different from each other. They don't look repetitive, although most of the operations have a high degree of repetitiveness. So these are really, really advanced sector. These companies in the past, they were focused only in the Japanese market. Nowadays, these companies are changing because the Japanese housing market is reducing a lot due to the decrease in demand for houses because of the age of the population and so on, which is something typical of developed countries. So these companies, they are very good at applying the concept of mass customization, right? So I'd like to explain a little bit more about mass customization because it's a very interesting concept. It was this mass customization ideas started to be discussed in the 1970s, and they are very much related to competition, right? To companies that have a competitive strategy, right? Which means they want to compete with other companies by offering products that fulfill customer-specific requirements, by having flexible processes and structure. So the company has a degree of flexibility that is related to the way processes are organized, but also in the structure of the company, right? So they have staff that are able to do activities with flexibility. That might be related, for instance, to the manufacturing plant. You might have multi-skilled workers. That might be related to the marketing area, design teams that are able to deal with flexibility. But the most important thing is these products, they have a limited range of products. It's not providing anything that the customer wants, but providing a limited range of products within costs and delivery time that are similar to mass production. So it is more expensive. It's not the cheapest product in the market, but the additional cost, the additional delivery time is not much higher than mass production. That's the idea. And this limited customization is based on a deep knowledge about customer requirements. So this contact with the customers that the Japanese companies have generates lots of knowledge about the customers. By doing that, for instance, by talking to the customer, seeing the customer visiting the showrooms, they're able to understand customer requirements, right? And the idea is that this customer is willing to pay a premium price for this customization, right? This is something that many companies in many that happen in many markets. For instance, we've done lots of work in mass customization here in Brazil, and something we notice even in housing for the, let's say, lower middle class, right? So if you deliver a standardized house, a standard house, right, to different people, the first thing people do before moving to the house is to change walls, change finishings, open a new window. They do lots of things because they want a house that fulfills the specific requirements. So these Japanese companies and some other companies from other parts of the world, they found this as a very important competitive strategy. And this is the studies we've done in housing, including social housing. We found out that providing a standard house, a standard product, results in poor value generation. Value generation is one of the most important principles in lean production, right? So one way of improving value generation is to consider the diversity of customer profiles. We have data from, well, this is from several years ago, but it's probably nowadays we have the same trend, right? Data that shows that traditional families, couple with kids, for instance, it's a small percentage of the demand, right? Something like 1/3, maybe in urban areas, less than that, right? And if you look at the housing programs in Brazil, for instance, housing programs funded by the government, well, it's actually, they think of, well, we want houses designed by a couple with 2 kids. That's a small percentage of the population. Many people work at home. There are many people who are single, different types of families. Very often you have 3 generations in the same house and so on. So mass customization is becoming more and more important. And what happened is that customization occurs anyway. People change a lot their houses. So this is an allotment for people that have a very, very low income. We've done a post-occupancy evaluation after a few years, and the houses have been completely changed and extended. One important thing is not to have a simplified view of mass customization, right? People think, well, I can have a printer of houses. I can do a flexible design. I can offer a choice menu for housing. That's too simplified. In fact, mass customization involves several fields of knowledge, right? It involves marketing, because you need to understand the requirements of the customer. It involves design. You need to design products that are suitable for that population. And you need to change the way, change your operations. Operations, I mean the production process, supply chain, logistics, and so on. And I find mass customization fascinating because of that. So these are some concepts that are involved in mass customization related to those three fields. You can find several concepts that are related to lean construction, for instance, visual management, pool production, client requirements management, the idea of having collaborative design. This is also very well explored in production, right? I'll show you some concepts. I'm not going to explain, of course, all of them. There are many. Just to give you an idea of how which type of knowledge is involved in mass customization, and as a consequence in modular construction, right? For instance, the concept of product modularity, right? So this is the most traditional type of modularity. I'm going to divide my product in modules. Each module has a different function, right? And each module can be produced by a different supplier or by a different production unit, right? And I have a standard interface between modules, so I can combine the modules in a different way, right? I can even have interchangeability between modules, right? So it's a very interesting concept, and that gives you opportunity to start to define a platform. So there is a set of modules that are used for several different products. That's when you can have standardized processes. So a number of modules you repeat, like in this hypothetical example, that that gray module is the platform. So it's involved in all products. The other components you can change, right? I can have a small inventory of that platform. If my manufacturing plant has a low demand in a certain part of the year, I can have an inventory. I can create an inventory of that product. This is an example of a study we did with some modular construction companies. Some of these companies have a very long catalog of of designs of houses, right? So, for instance, what is a very large catalog? We have 200 options, and as the company sells more, this catalog grows a lot, right? Which creates a burden of choice. It's difficult for the customer to make a decision. We did a study in one of these companies, right? So these are 4 different designs of houses that were extracted from a catalog. And then by making some minor adjustments, we can have a platform, a product platform. We can have a set of standard modules that are going to be repeated in different types of housing design, right? So I can store some of these components if I have some period of low demand. I can even sell the house in a different way. For instance, I can tell the customer, well, choose a platform. So this is a platform for a 1 floor, a 3-bedroom house. And then you can add some additional modules depending on how much you want to spend, which kind of things you want to have in your house, how many cars you have, and so on. So this is a very powerful concept, product modularity, which is not fully explored by most modular construction companies. Well, in some projects, you cannot have product modularity. Let's say, well, I'm going to build an industrial building, and there's no complete repetition between parts of the building. But I can still use the concept of process modularity. So I divide my building in small batches. This is a Medabil project. Medabil is a steel fabricator. In each batch, you have a similar set of tasks, right? And so you have repetition in the process, although you don't have full repetition in the product. This is another project we did. It's a parking building in Porto Alegre Airport. So we divided that building in batches, vertical batches of 4 floors. And then we created repetition. We could use the idea of tack production, right? So this is something that has been adopted by many modular construction companies. So here you can see it's much more about operations, right? So the product modularity is about design. Here we're talking about operations. And there is a third type of modularity, which is supply chain modularity, is when the supplier is interchangeable, right? When you want to have open industrialization, we want to involve different supply chain members in the production of industrialized building. This is a company, Connects Tech. It's a company that adopts this idea of supply chain modularity. It's very well explained in the paper written by my colleague Daniela Viana. She used to be my PhD student. And then by using this idea of supply chain modularity, we can start implementing modular construction gradually. So this is one way of implementing modular construction. The Japanese companies, the Swedish companies that are described in Elena Lidlow's paper, they typically come from another sector, right? From car industry, from timber industry, from chemical industries, right? So these are not construction companies that become modular, but there are other way of implementing modular construction by, for instance, real estate companies. They might start combining modules produced by different companies, modules for facades, modules for bathrooms, modules for kits, electrical wiring kits, plumbing kits, right? So some companies from the real estate market are trying to implement that. Again, in this type of implementation, it's very, very important to use some lean production ideas. Pool production is very important. Prototyping. There are many different practices related to lean production that makes this type of implementation feasible. And I'm not going to talk a lot about that, but there are also so many customer integration practices that can be used. These are some studies that we have developed in Brazil by for how to expose the different housing options to customers, how to assess the willingness to pay. This is really important. The customer wants to have customization, but is the customer willing to pay an additional price for that? There are techniques that helps you on assessing that. How to devise a choice menu that is useful, a choice menu that will not create a false expectation in the customer, right? So we've done a study on that as well. And these are studies that we've done in manufacturing plants and construction sites on the implementation of lean production to support modular construction. This is Visia, this company that is from Rio Grande do Sul. We've been working with them for more than 3 years, and they have had a very impressive digital transformation in the manufacturing plant. As I mentioned before, they used to have a construction site under a roof, and now they have a production line. Of course, it's not as advanced as in Japan, but they are evolving quickly, and they are using some ideas that they are very much based on the lean production philosophy. The use of standardized work for reducing the cycle time, unknown systems, visual management. It's a company also that emphasizes continuous improvement a lot. They have a wonderful transformation process in the implementation of lean, but of course they're far away from the Japanese. Recently, the manufacturing plant celebrated the fact that they can produce 3 modules a day, right? If you can remember the numbers from Japanese companies, they produce 3 houses a day, right? That's around 36, 40 modules a day. So it's much higher throughput. Of course, they are bigger plants, but they have a cycle time of 3 minutes, of 5 minutes, takt time of 5 minutes, which is something remarkable. They are also using some lean ideas for site installation, which includes the assembly of modular components, but also for the production of the non-modular part of the project. So you can see line of balance, you can see the control of takt time, you can see visualization techniques using BIM, you can see the last planner system, visual management, and so on. And they are also in these implementations, we need a different types of metrics for controlling different things. We need to control work in progress. We need to control the rhythm of different processes. We need to control cycle time, things like that. So we've been working a lot in our group on how to measure performance in those production systems. And of course, digital technologies, some of the technologies from Industry 4.0, they are really important because they can provide real-time data. We can create databases, we can analyze that data, we can extract knowledge from that data. So this is a very important way. Just to finalize, I'd like to emphasize something that is really important for keeping the effort of making construction more industrialized, which is sustainability. Of course, industrialized construction contributes to environmental sustainability, especially by the reduction of material waste, reduction in the consumption of energy, using a wide range of materials that have a much smaller environmental impact, right? But also modular construction can contribute to social sustainability by improving working conditions, by eliminating risks of certain accidents. It's also contributes to social sustainability to considering diversity of user, diversity of requirements, right? And finally, modular construction can make environmental sustainability and social sustainability feasible because of economic sustainability. So we need to achieve cost reductions. We need to reduce indirect costs. We need to reduce rework, improvisation that will make construction more competitive. So my final slide now. There are many opportunities for combining this industrialization approach that I presented today, which is a combination of modular construction and mass customization. So combining this industrialization approach with digital technologies and with lean management, right? So we need studies that combine those three topics, or at least two of those three topics. That would be an advance. We should avoid studies that are just focused on lean or modular construction or digital technology. We need to integrate this type of research effort. We also need to adapt some of these ideas that have been developed for manufacturing into the construction industry. So these concepts, pool production, takt time, work in progress control, and so on, this needs to be adapted to the construction industry. We cannot copy that from manufacturing. So there are many new demands for research and development. For instance, methods for understanding demand for customization, right? Capturing requirements, analyzing trade-offs, things like that. We need to explore more the concept of modularity, different types of modularities, as I mentioned before. And we need to develop studies on the flexibility of production system. This is very important for making modular construction competitive. There are many companies that invest in advanced manufacturing plants, but they just want to sell standard modules. Many of those companies, they stop their operations because it's very difficult to get a market for that. So the companies that are more competitive in modular construction are the ones that have flexibility, that adopt some of those lean concepts that I mentioned before, that enable the companies to adapt to different demands, right? One example is the big flood of 2024. We had suddenly a very large demand for modular construction, but the companies had to adapt quickly to fulfill a very specific demand that came out. And unfortunately, it was not very easy to make those modular construction projects feasible. So there are some, but we expected to get much more benefits of modular construction after that extreme climate event.